Okay, so in this exercise we'll be doing test-driven development in Node. This exercise is Fibonaccis, and we'll be using JavaScript preferring const over let over var. We'll have automatic linting from ES6. We'll use Mocha and Chai to drive our tests and expectations. We'll use arrow functions. We'll have some negative tests, make sure we cover those, and we'll look to do some refactoring. Alright, let's get started. Okay, let's get set up. I'm going to share this setup between all of my exercises to make it a little bit easier. So let's get going. So I'm going to create a directory to work in, app. And you see our Explorer here is keeping up with us. This is VS Code. I'm going to go into that directory, and I'm going to use Node, so I'm going to create my package.json file. There it is. It's a simple template. And let's start installing the tools I'm going to use. And they're going to be dev tools. So this is first of all for testing, Mocha and Chai, Chai for expectations. And then ESLint and ESLint plugin Mocha, because I'm using Mocha. Alright, and then one final thing while I'm at it, I might as well install NYC for code coverage while I'm here. It's a successor to Istanbul. Okay, good, so that's the three of those. You can see our package.json file. It's got our dependencies. It doesn't do anything with our test command yet, so I need to fix that. But first of all, let's copy in this ESLint RC YAML file that I've got. And you can see here, there's a ton of rules. I love having loads of rules to guide me, you know, in errors and warnings. So it's very, very handy. I love that. Alright, that's the ESLint YAML file. And here's our scripts where we want to actually put in running tests. So let's put in the actual command we're going to use, which is going to be Mocha. We'll just use the top level, anything that's called star.test.js. Okay, so we should actually be pretty close to be able to run tests. Let's try to do it with npm test. And no files found, but no actual error. So let's go ahead. We'll use index because that's what the auto generation of the package.json used. And we'll put in our index.test.js, which is actually the file it'll recognize. Alright, so it's green. No test, but the framework's there. Alright, so let's put in the other pieces now. Let's put in the linting, which is going to be our pre-test, so it's going to run before the tests can even run, and that's going to be ESLint everything. And while we're here, let's put in our code coverage, and that's going to be the NYC npm run test. So that's close to all of the pieces we need. We can run our tests again to make sure that they work, and we can run code coverage to make sure that that works. And you can see that we didn't have any files again, but this is the expected output that we've got. So we've got our linting, our testing, our code coverage, our basic files set up here, NYC output for code coverage output. So we're pretty much ready to go. So now we can go ahead and create the actual app. Alright, let's get started. And let's have our index and test files. And let's get started with the testing straight away. So let's pull in our test library. So that's going to be Chai. So we'll include that. And then we'll pull in our application code. So we'll name that here Fibonaccis. That's going to come from our standard these exercises index file. So we'll include that. And let's just write a test. So let's describe this well. So put it in quotes. So we want this to provide a list. Provides a list of n Fibonaccis. That's what we want this function to do. So that's the goal. So let's do the first example. And so let's just step through the first few Fibonaccis. So it's going to call this function, which we've named on line 3. Well, it doesn't really exist, so this should probably fail, right? Put our semicolons in. Let's try and run it. Expect is not a function because I missed off the .expect. Let's add that in. Okay, let's try that. Alright, let's run the update. Line copying, I'll just type it. This is usually very quick, so why not do it? Done. Okay, back to testing. That actually passed, which was somewhat surprising, because I haven't actually defined it. I was actually surprised myself. So, maybe it's because this one didn't also have use strict. Let's put that in both files. And let's try without it. Yeah, it still gets it. It's interesting. Oops. Let's go back here and put it back in. Alright. Oh, I didn't have the braces around it. So by sticking it here, I required the file, it passed. That was interesting. Now it's giving the error I expected, which is expected undefined to exist. So now we're going to put it on a modular that exports. And we're going to use that name we've decided on already in the test. And this is going to be an arrow function. And let's see. We just want the test to pass. What's the minimum to do that? So what if we just do return true? Try running that. Makes the test pass. Alright, so let's force the application code with another test. Let's test first. So let's say give us one Fibonacci, the simplest possible thing we can do. So we're going to tell it how many we want. Oops. And we expect the result of that to be EQL. So that would be a little array of 0. So let's try that out. Let's try running that. We can treat it deeply equals 0. Well, of course, because this returned true. So I could do that. Let's try running that. Yeah, that actually makes them both pass. So it's not really code yet, but it's slowly stepping into it. That's the purpose of this exercise. So let's do 2 Fibonacci's. Now we're actually going to have a series coming back, and that would be 0 and 1. So that gets a little bit more interesting. So obviously that's going to fail. Let's see, 0 does not equal 0, 1. So now I actually need some code. So let's comment this out immediately. And so we're going to read this list of Fibonacci. It's going to be an array, so we can decide that like there, and then at the end it's going to return whatever we've put into that array. So there's going to be some code in between here after we put our semicolons in. Okay, and we keep these 2 numbers with a Fibonacci. Keep adding the last 2 numbers. So we know it's current number, which will start at 0, and the next number will start at 1. They're both 0. We'll never increment. So you get 0, 1, 1. Thank you. Autocomplete. All right, semicolons. Alright, so now we're going to have a loop, so we're going to have a for loop. We're going to use I, go from 1 up to however many, so let's call it how many, and that's what we're going to actually pass in. We're going to name that parameter how many. So until we get to the number we want, we're going to increment I. And within here, we're going to add to the Fibonacci's array, so we'll push this value current onto it, and we'll need to do something else now to change current. We'll want to add on next. That might not be right, but let's try that without even looking the formula up. See if that'll work the way we've got it structured here. Actually, maybe it should be I. Let's try it. Let's run the tests. Okay, current is not defined. That also needs to be given a type. With use strict, okay. So let's try running that. Next is assigned a value and never used, right. So we actually wanted to try doing this. Let's try that calculation, see if that works. I is not defined. Let's see for I. Let's put a const on this, actually a let. And let's try running that. That's an unusual message. It's actually wrong, I think. But oh, there it is. It's the that is not a 1, it's an I. I might have spotted that. Okay. Let's try putting spaces in. Actually makes that a little clearer. So you can see why that's recommended. Although I don't really like it here at the end, so let's leave that I++. Yeah, these are actually going to change, so let's make this a let. Let's make this one a let as well. Okay, so let's try that. Next is never reassign. We're still getting that. This is not the right formula yet. We actually want to change next as well. And semicolon. Okay. That actually passes. Alright, so that's 2 Fibonacci's. Let's see if it'll go for 3. I don't think it's quite there yet, so let's just step one more step in. So this should be 0, 1, 1. Pretty simple, so let's see what we get. No, not 0, 1, 2. Not 0, 1, 1. So this is not quite right yet. Let's take a look at it. Yes, push the current one. Maybe these should be reversed in different order like that. And let's see. Maybe we should say there's going to be the newer one is the current plus the next. Then we change the next. Then we change the current to be the next. Right, let's try that. Semicolon, of course. Yep. Okay, run that. Newer. Oh, I've got to put. Let's give that a type. So it's going to be a const. And oh, this was supposed to be newer, not next. All right. Okay, I think that's good. Yes, passing. All right, excellent. That is all good and it makes sense. It's very readable, I think, with those names. So I think that's actually good. I'm going to jump ahead now. And do 9 for our next test case here. We can always backtrack, but let's go for it, because we don't want to test every single number. We want to make jumps when we can. This one might be an early one, but we know the sequence here because we use them all the time in story pointing. So let's run this, and that worked right off the bat. So we have actually got our formula in pretty good shape. All right, so now maybe we could have some exception testing. What if we say 0 Fibonacci's, and that should just give us well, we also have to decide here and hope we get the right one. Let's get an empty array. Yes, that actually worked well. So what other negative or sad cases could we do? Well, what if I actually don't, no parameter at all? Why don't we try doing that? So don't even put the 0, and let's say we want to get an empty array. Let's say that's the behavior we expected. That's good. Alright, so that's pretty good. Let's see. What about a string? Now we're really testing out some different stuff. And we'll say that should give us an empty array as well. So we'll pass in example string. And that should just give us that empty array. Let's see if it does. Nice. So no code was actually needed for that. Let's clean things up. Let's get rid of that comment. This is looking pretty good here. And it's still passing good. And when everything's passing, I always run coverage. Yep, we got 100% coverage. It's linting, fine. Testing, fine. Coverage is fine. One of the final things I always think, what could I clean up? Literally test perhaps I could remove. Let's take a look at the whole list of them here. So at this point we probably don't need the canary test to make sure that the function exists. And we could probably get rid of the 3 Fibonacci's as well. Okay, that shrunk it down a little, but all the things I want to see tested are good. Let's see if we can run that again, if it doesn't crash. Okay, those all pass.